Our next speaker is a very distinguished guest. He is going to talk about basically what makes consciousness, like how do we know that we are here? Ironically, his last name is Aru. So let's please have some warm applause for the brain guy, Mr. Jaan Aru.
Thank you. So I am really fascinated about brains. So I would love to come to you, open up your skull. And then if I would do that, I would see your brain. If I would dig a bit deeper, I could see the neurons, the nerve cells, and the web of their connections. I could monitor their activity, and if I would look inside them, I would see all kinds of biochemical cascades. So from that perspective, you're a machine. A very complicated machine, a biological machine, but nevertheless, just a machine. Now, the funny thing is, I bet you don't feel like a machine. You have your thoughts, feelings, your sense of being someone, your sense of being you, you have your consciousness. Now, the problem of consciousness is how do these two perspectives, the machine in your brain and your conscious experience, fit together? How can the neural machinery give rise to your conscious experience? For example, today in the morning I cut my finger. I did not do it to have a good example for this talk. I'm just clumsy, right? But when I did that, I felt pain, and then I started wondering, okay, I understand how this information is transmitted to the brain, and I understand some of what's going on in the brain. But what I don't understand is how and why these physical processes in my body give rise to this feeling of pain. So in our current laws of nature, there is no explanation of why matter and processes in our physical body should give rise to mind and consciousness. And this is very, very strange because consciousness is a crucial aspect of our life, of course. If you would lose your arm, it would be devastating, but you could still feel, think, love, be yourself, but consider having no consciousness. In fact, you cannot imagine it because there simply would be nothing for you. No experience, nothing. No feeling, no thinking, no experience, no you, simply nothing. So it has been said that consciousness is everything we have and everything we are. So to understand ourselves and who we are, we need to understand consciousness. There might be two relatively boring solutions to the problem of consciousness. The first is that the brain and the mind are not connected at all, that they are different. And indeed, many people have this intuition that the brain and consciousness have to be different. They just seem so different. But we of course know that our intuitions fail us. So, for example, many people thought that not so long ago that the Earth is flat, but this is plainly wrong. So it can be that although we feel that consciousness is different from the brain, it actually still is connected to the brain. So in fact you know it. So if you have taken too much coffee or too much alcohol, you know your consciousness radically changes. But even better set of evidence for this claim comes from studies of brain stimulation. So if someone here would tell me, no, I don't believe what you're saying, I don't believe that my consciousness is in my brain, then I could come to you, again open up your skull, and put a tiny electrode into your brain, a tiny wire through which I can pass some electrical current. Now, the point is that through that current, I could now change your conscious experience, your thoughts, your feelings, simply by passing current through different brain areas in a specific manner. So for example, a very simple example would be that if I give electrical current here to the back of your head, you would experience flashes of light here in the right visual field. If I would go a bit higher, very systematically, then these flashes of light would start moving. If I would switch to the other hemisphere and simulate there, these flashes of light would appear in your other visual field. So there is an orderly correspondence between what I do in your brain and what you experience. Okay, you might not be very convinced, so I could do the following thing. I could ask you to come here and have a look at this scene of this great audience and stimulate you at the part of your brain that processes faces. And you would experience something very strange. So you would perceive these people, you would perceive these bodies, these chairs, you would hear what they're saying, but their faces would morph into something that you cannot understand. You would not perceive these faces. So if I would take the stimulation off, again, everything would be normal. If I stimulate again, your conscious experience of the faces disappears, everything else stays intact. So I could mess with your conscious experience by messing with your brain. Now again, some of you might say, oh, this is boring, because conscious experience and consciousness is about having will to do things, and you only have manipulated conscious experience. Well, fair enough. I could put the electrode to the right parietal cortex here, and if I search well enough, I might find an area where if I stimulate, you would feel the urge to do a movement, a particular movement, maybe something like this, right? Every time I stimulate there, you feel the urge to do this movement. You won't do it, but you feel it, that you want to do this movement. If I take my electrode off, you don't feel it. So I can manipulate your will, your urge, or your wanting of doing something. So it seems that there is this orderly correspondence between what goes on in your brain and what I do in your brain and your conscious experience. And the easiest explanation for this is that indeed your consciousness is in your brain. Now, the other boring solution would be if every kind of neural activity would be associated with consciousness. But this is not the case. We know that, in fact, most of the processes going on in your brain never reach consciousness. So most of the stuff going on in here remains unconscious, which means that there have to be specific mechanisms for your consciousness. Now I could, as an example, I would need a spoon and a volunteer. I saw that my spoon just ran out of the room, so I won't have a spoon, so let me just tell you what I would do. I would take the spoon and with the help of the spoon try to remove a part of your brain. So it is a joke, of course. Now, if I would like to remove your cerebellum, your small brain, and don't get distracted by the name. It is actually, the cerebellum contains roughly half of your brain's neurons. So it is a very mighty organ. Now my spoon returned, but you already passed the moment. Next time, Silver. Okay, so the funny thing is that if I would take the spoon and remove your cerebellum, then essentially nothing would happen to your conscious experience. You would still be yourself, you would still have the same conscious experience. Well, you would not be very good at playing piano or playing soccer or doing anything like that, but your conscious experience would stay the same. And think about it, I just removed roughly half of your brain's neurons. Nothing happened to your conscious experience. So this shows that first, your fine motor coordination happens in cerebellum. You need it for playing piano, playing soccer, etc. Secondly, this all goes on totally without your consciousness. Everything happens unconsciously. And third of all, this implies that there have to be some specific neural mechanisms that are related to consciousness. Now, so we would like to understand which specific mechanisms and how give rise to consciousness. And such understanding can be achieved through science. Some people might say, well, consciousness is not a scientific problem. It's way too complicated, way too vague, and by the way, we're dealing with subjective phenomena, so this cannot be science. But science is about trying to find things out. And the task of a scientist is to find ways how to study this very complicated phenomena. So in science, we are on the border between the known and the unknown. And with science, we try step by step to occupy the pieces of the unknown and extend the borders of human knowledge. So, I mean, think about it. Through science, we already know astonishing facts about our universe, life, or the quantum world, topics that were considered incomprehensible just a century ago. So why couldn't we understand consciousness? I think we should at least try. So science is about trying to find things out. And indeed, since the beginning of the 1990s, scientists have tried to figure out how consciousness relates to the brain. In particular, the Nobel Prize winner and the co-founder of the DNA double helix, Francis Crick, was one of those who pushed this field of consciousness studies very hard. So he said in 1990 that time is ripe now for a scientific attack on the neural basis of consciousness. In particular, he said that, look, philosophers have worked on this problem for 2,000 years, and they have achieved absolutely nothing. Now it's time for us, scientists, to take over and do what we do best. So do experiments, measurements, and figure out what consciousness is. Now, Francis Crick was definitely too pessimistic about the role of philosophers, and he was way too optimistic about what science can achieve, because in 1996 he wrote, with a little glimpse of luck, we might find the outline of a solution to the problem of consciousness between the end of the century. And of course, the end of the century passed without anything happening with the problem of consciousness. And Francis Crick died in 2004. The problem of consciousness was still there. Hey, today we're still talking about the problem of consciousness. So over these last 25 years, scientists understood that, well, this is a really, really tough problem. And many scientists indeed consider this now as one of the fundamental challenges for modern science, because we simply have no clue how the brain could generate consciousness. And yet, this is the thing that we need to understand if we want to understand who we are. So the problem of consciousness brings us directly to the border of human knowledge. As said, we would like to extend that border. We would like to occupy pieces of the unknown. So how does one do that? How can one go beyond what's already known? In our case, how could one solve the problem of consciousness? If I would know that, I would not be standing here. I would be in my lab doing research, or in the best case scenario, I would already be looking for a nice suit to wear at the Nobel Prize ceremony. But I'm here. So obviously, we're not really close to solving the problem of consciousness. So we should ask, what's the next step to take? And I think pretty much everyone who has thought about it would say that the next step is that if we want to understand consciousness, we need to understand and measure the activity of tens of thousands, hundreds of thousands of neurons simultaneously. So let me try to explain to you. In your brain, you have roughly 100 billion neurons. That's a lot. That's 1 with 11 zeros. Each of these neurons is connected to roughly 10,000 other neurons. So the number of connections is enormous. And these connection patterns are specific. So if I would come and slice your brain and your brain and your brain, then all of these brains would be different. In fact, it's thought that really your brain architecture, the connectivity of your brain, makes you you. So your memories, your identity, your personality is coded in this connectivity pattern. So this also implies that this connectivity pattern is constantly changing. For example, now when I'm giving this talk, there are new connections being formed in your brain. So, sorry, I might ruin your brain. Okay, more importantly, on top of this connectivity, there are activation patterns. So neurons communicate with small electrical impulses, but you must imagine that there are millions and millions of neurons active at the same time. So it looks like very cool fireworks. And it is, of course, a very special fireworks, because these activity patterns running on top of this connectivity carry the meaning for the brain, and they allow you to do everything you do. So if you talk or walk or think, then these are based on these electrical activity patterns running around in your brain. So, and of course it is thought that consciousness also somehow emerges out of these dynamics of these electrical activity patterns. So we would like to understand these patterns, but it is in fact very difficult to do because up to now, neuroscientists can maybe measure at the same time, let's say, 100 of neurons at the same time. But as said, we would like to measure 10,000 neurons, maybe 100,000 neurons, and the more the better. And it is technologically complicated, and you understand why, if you remember that I told you that you have 100 billion neurons in your brain. So each of them is very, very tiny. So to measure them, you would need essentially either very, very thin wires and thousands of them, or you would need new kinds of technology, for example, nanotechnology. Fortunately, many clever people in the US and in Europe are working on these technological solutions. And fortunately enough, also, the European Union and the US government have both said that they will support the mapping of brain activity now. Of course, European Union and US government are not so much interested in solving the grand problem of consciousness. For them, it's more about the fact that if you have this very complex system like the brain, many things can go wrong easily. So probably you have heard of the terms schizophrenia, Alzheimer, autism. Maybe yourself you have had depression. Maybe you have thought of that, but they are all, of course, brain diseases. So something is different or wrong in the brain. And maybe you never realized, but these diseases are much more common than you might think, and they are very costly, of course, for the patient, for the families, but also for the society. For example, in the year 2010, it was estimated that in the European Union alone, the total cost for brain diseases was 800 billion euros. So 8 with 11 zeros, only in Europe, in 1 year. So we would like to reduce that cost, but of course, we would actually like to help these people. And to do that, we need to understand how the brain works. To understand how the brain works, we need to measure these activity patterns. To measure them, we need new technologies. Thus, it makes sense that in the US, there are 2 super projects now going on that try to map these brain activities. So first of all, the co-founder of Microsoft, Paul Allen, gave $300 million to map brain activity. And now the US federal government has also announced that they will put the money for brain research into their annual budget over the next years. And this project was now kicked off or launched by President Obama with a cool $100 million. So there's money for brain research and for mapping the brain activity. However, we shouldn't fool ourselves. So simply mapping the brain activity or measuring it won't solve the problem, because you cannot understand a complex system like that by simply looking at its activity. So these patterns that you would see would mean essentially nothing for you. So we need to learn to understand and interpret them. And therefore, neuroscientists need help from engineers, computer scientists, mathematicians, physicists, who have the mental tools for dealing with such data sets. I mean, even they don't have, because nobody has really worked with these kinds of data sets where information comes from 10,000 or 100,000 neurons, but they could help us. So we need to go further even than simple data analysis. We need to understand how the brain works, and this understanding in science generally comes through theories that are formulated with a mathematical language. So we again need computer scientists, mathematicians, to help us try to formulate theories about how the computations in the brain work. So this is called computational neuroscience, and I am very glad that just now this summer a new group for studying computational neuroscience was established in the University of Tartu. So one tool or one thing that the computational neuroscientists do is that they work with models. I should say that we don't work with supermodels or underwear models, but we work with models of the brain, with brain simulations. So at first it might sound less interesting, but actually it is more interesting because we try to understand how the brain works. And there is a very large-scale modeling effort going on in the European Union where people try to simulate the whole human brain. And the European Union is supporting this project with 1 billion euros. So it's a lot of money going into a computer game, basically. So it's a very fascinating computer game, of course, because we try to do a simulation or a model of our own brain. And if you would have a model, then the advantage of a model is that you can switch off certain things, switch on certain processes, change parameters, and through that try to understand how the brain works. Now this is easier said than done because we simply don't know the bits and pieces of our brain. So how can we build a model of something that we don't know? We don't know the details to put into the model. But of course, these people say that, yes, over these 10 years, we will learn much more about the human brain. Let's see, let's hope so. The other problem is, of course, that maybe we will have this exact, very good replica of the human brain, but as it is so complicated as our own brain, we simply won't understand it. Well, we'll see. I mean, it will anyway be a great journey, and we will learn a lot about the brain. So, in the end, let me return to the question, or let me come back to the problem of consciousness. Will these big projects and the huge amount of money devoted to them tell us anything new about the relationship between the brain activity and conscious experience? I don't know. It is impossible to predict what will happen because when we are marching into the unknown territory, we of course don't know what will wait for us there. But as we have never seen the brain activity in such a resolution, it might be that once we see it, once we analyze it, try to understand it, the way this activity is, changes, organizes itself, gives us very strong hints about what consciousness is. Or if we are building this model or have this big model of the human brain, that we indeed find some crucial insights about how the brain works that in the future help us to solve the problem of consciousness. So, although sometimes I have severe doubts about my own intellectual capabilities, and sometimes I have doubts about the problem of consciousness, which just seems too complicated, too philosophical, then I try to remind myself that in the fight with the unknown, we cannot foresee what the future will bring. So, although it might be that I will never see how the problem of consciousness gets solved, I am willing to take that risk. Because if we aim high and try to solve the problem of consciousness, we are going to step by step occupy the pieces of the unknown and extend the borders of human knowledge. And I want to be part of that because on the way we will learn amazing things about our brains and ourselves. Thank you very much.
Thank you very much, Jaan. After each speaker, we're going to have a question and answer session, and Pauline will bring a microphone to you. If you have a question, please just raise your hand. I would like to open the question and answer session with, I would be very interested to hear your thoughts on free will. That has been a very popular topic in the past few years. Do you think that you came to speak here of your own free will? Did you choose to come, or are you here as a result of a complex series of mathematical equations?
It's a pretty good question for a comedian. Just joking. So I touched the topic of will a bit, right? Because I told that there are certain areas in the brain where if I stimulate them, you would feel the urge or will to do something, maybe a movement like this, for example, right?
Pulp Fiction.
And you can show with brain imaging that if you give the persons a task to freely decide which button to push, for example, then you can predict from the brain activity what this person is going to do 8 seconds in advance when this person is going to do it. So this, of course, throws a lot of questions about, what is the brain doing? Can the brain really predict what I am going to do? For me, this is a wrong question because if I am my brain and my brain connectivity, then there is no fight between me and my brain. We're the same. So it comes down to another question, which was the original question actually. So can you mathematically model all of these equations and things which will predict what I do next and what I want next? And the answer is simply no. So in principle, this cannot be done because of, so one reason is the Heisenberg uncertainty rule. So you cannot really predict everything that you would need, all the particles basically that you would need to capture. And we know from the chaotic systems that if you cannot predict or if you cannot measure with a very good precision, then you cannot predict what this system is going to do. Even more simple systems than my brain. So the answer is no. You cannot predict it, but this does not mean exactly that you have really like free will in the sense that something from another universe comes and interferes with what you're doing. So we need to think and maybe redefine of what we think with what we mean by free will. It was a long answer to a very simple question. As you see, I'm almost doing philosophy here. Huh?
So that means he did not want to come here today. Thank you very much. Do we have any other questions? Yes.
I have a question. I have a question. Can I just speak?
You are allowed to speak.
Please speak to the microphone.
Just hold it. You know, it's cool. Looks cool.
Anyway, what do neuroscientists think of like this problem with people are born and they just learn things through experiences, they are socialized, or they are born with something already? Like all this thing about kind of talents and being...
Yeah, I mean, we know this is the classical nature versus nurture debate of what determines this. And the truth is both are right, or it's an interaction. So certainly, if you're born, you already have your specific brain connectivity pattern. So if I would slice up infant brains, I won't do that today, okay? Then these brains would be different already. These connectivity patterns come partly from the genes, but already in the mother belly, there are activity processes which can be termed as experience. So, for example, what the infant hears through the womb, and but also, for example, how the infant itself or himself moves in the womb. These things will generate activity patterns in the brain that will change the connectivity and so on. So some basic things are in the genes, but these is all modifiable by the environment. So both are right, and if we want to have a nice and healthy baby, we should take care of both of this. With genes, it's a bit more difficult, but you have to find a good man. Then it's done, and then you have to provide a nice environment.
Okay, I'd like to point out that the microphone is on. It's just for recording purposes only. Did we have another question over on this side? Yes.
I was just wondering about your opinion on something. Jeff Hawkins, he's an influential, inspiring computer scientist turned neuroscientist who's defined as one of his goals to create intelligent machines and to dissect the nature of intelligence. And he's approaching it from the angle of discovering and replicating a cortical algorithm for intelligence and then inserting it into a machine, and then it will be able to predict the environment and evolve and learn like humans do. So I was just wondering, what's your opinion? Can you actually separate the nature of intelligence, which is also part, I think, of the conscious experience, from other parts such as emotion and the whole interaction between the different parts of the brain? Because basically what he's saying is, you just put the cortex, or just prefrontal cortex maybe, when you just put that algorithm in a machine, and it might be able to learn without the emotional part. So it's a broad topic, but what's your ideas on that?
Great question. Obviously, you know a bit or two about psychology and neuroscience. So one goal of what Jeff Hawkins is doing is really just to create good machine algorithms that could, for example, recognize people and things, for example, on images. So some years ago, the computers were still very, very bad at this, and we do it effortlessly. So for that, these algorithms are pretty good, although there are better ones. But the real question and the good question you ask is, can you run intelligence without the other functions? And in our brain, they are definitely all intervened. So there are people who say, these emotions, they don't need them and so on. But nobody has really good experimental evidence for showing that you don't need emotions. And if you look at the brain, there's nothing like strict modules that only do one thing. So it's a very complicated network of hubs that do a bit different things. But the magic happens when they work together, when they all interact.
Right, I think we have enough time for one more question, if there are any more. Yes?
Yes, thank you. Well, speaking about brains, can you tell us where new ideas appear? Is it in our consciousness or unconsciousness? And as a neuroscientist, can you just open our brain, our skull, and put something in there, and then touch our neurons, so we get more new ideas?
Yeah, so
can you just manipulate this process?
yeah, so this question about new ideas or creativity is a great one, because although many people intuitively would think that how you come up with great ideas, that you think consciously and then you come up with the idea. But this is not how it happens. So artists know it, but also mathematicians tell me that if they're solving, for example, a mathematical task, which is very complex, then they think about it and they don't find the solution, but often the solution suddenly comes to their mind, to their consciousness, and artists tell the same. And there are, of course, many famous anecdotes of people coming to great solutions in the bathtub or while walking and so on. So the answer seems pretty clear that most of these very creative things happen in our unconscious processing, in the parts of the brain that we really don't have conscious access to, but they then appear in our consciousness. Now, with humans, there are a few works of where people have tried to enhance creativity through brain stimulation, for example. So actually, I shouldn't do that like that I open your brain and put the electrode in and let's stretch current. Shouldn't do that. So, but we can do it, for example, in Tallinn, in the lab of Talis Bachmann, we do have transcranial magnetic stimulation, where a brief magnetic pulse or magnetic field is induced that changes the activity of your neurons in the brain. And with these methods, people have tried to enhance creativity a bit, but the results are not very clear. But this is certainly a topic that over the next years will generate a lot of interesting new results.
Okay, thank you very much. Jaan Aru, ladies and gentlemen. I personally would have hours of questions to ask him. I think this was very fascinating. One of the things that I would love to know more about was, I've been reading recently that we've all seen the movie The Matrix, right? Okay, there is recent evidence that points out that we, in fact, do live in a computer simulation. So that will blow your mind, as the program here states.